The periodic table. In this chapter of periodic table, according to the NA syllabus, the textbook is chapter 12, and for the O level combined science is chapter 14. Because the coverage are quite similar, so we'll go through together for the NA and Express. Now there are 5 areas to cover under these chapters. First is the features of periodic table, and then the periodic trends, then followed by the group 1 elements, alkali metals, their properties and reactions and so on, and then followed by the group 7 elements, halogens, also their properties and their reactions, and then last but not least is the group 0 elements, the noble gas. Now for the first section, describe the periodic table as an arrangement of the elements according to the proton number or the atomic number. So let's focus on this. Arrangement of element according to the proton or the atomic number. You don't have to write both, just write one will do. Proton number or atomic number, either one. So what is a periodic table? What is the periodic table referring to? Actually, the periodic table is actually a list of elements arranged in order of increasing proton numbers. So if you look at this, is a typical periodic table. Alright. So in this, they go by row. So this is the first row, followed by a second row, and so on. So the first row, there are 2 elements. Okay, look at the number here. This is proton number 1, 2, followed by 3, 4, 5, 6, and so on. You go from row by row, from top down, then from left to the right. All these are the proton number of the elements. And take note, look carefully. There's no 2 elements having the same proton number. There's no 2 elements having the same proton number. So it's according to the increasing proton number. Now this is the actual periodic table. If you look carefully here, if you cannot read the periodic table, you don't know what the number refer to, look at this one, it's called key. Okay, the first row on top, this is called a proton number. First number on top is proton number, like this for example. And then the next one is a symbol, followed by the name, followed by the mass. So the mass is the one at the bottom. I'm sure you know this. Alright. Periods. Period runs horizontally across from the left to the right. They are numbered from 1 to 7. So how does the period look like? It looks like this. Okay, this is period number 1. That consists of only hydrogen and helium. And then period number 2, it consists of lithium, beryllium, boron, and so on. So altogether, there are 7 periods. Now, it's easier to count from the right hand side. Okay, if you look at the left hand side, if you start counting from lithium as period number 1, then you make a mistake. Some people think that sodium is period number 2, but in actual fact, sodium is period number 3. Alright, so if you count from the left hand side, right hand side, you will not miss. It's 1, 2, 3, and so on. Groups. Group runs vertically down from the top to the bottom. So they are numbered from 1 to 7 and 0. So there are 8 groups altogether. For example, this is group 1. All these are in the group 1. And this is group 2. And this is a group 3. And group 4 and so on. Until group 0 here. The center block between the group 2 and 3 is called transition metals. Okay, between group 2 and 3, all these are called transition metals. Okay, checkpoint 1. Which property of an atom determines the position of the elements in the periodic table? Which one determines the position? So in other words, how are elements arranged? Answer is proton number. Okay, they are arranged according to the proton number. The periodic trends. In this section, you are learning about the change in metallic properties of elements across the period of the periodic table. And then also relate the position of the element to its proton number and electronic structure. In other words, in which row and which column this element is placed depends on its proton number and its electronic structure. And describe relationship between the group number of valence electrons, and the metallic and non-metallic properties, and explain the similarities between the elements in the same group of the periodic table. So this is a simplified periodic table showing you only the proton number. Now you look at this, there's a zigzag line that divides between here, you can see that. So this zigzag line, which I highlighted in red here, actually can run from here, run from this spot, from hydrogen, divides the metals from the non-metals. So if you look very carefully here, the yellow colors are all the metals and the blue are the non-metals. These are the metals, these are all the metals, and these are all the non-metals. Blue are non-metals. Now the metalloid lies between the metal and non-metal. So what are metalloids? Metalloids are elements with property of both the metals and non-metal. So they have some property of metal and some property of non-metals. You will not be asked to define what's metalloid. Just take note that metalloid is actually above and below the zigzag line, the staircase. Except aluminium, aluminium is a metal. So this is the typical periodic table. So let's check some question here. Now, is hydrogen a metal or non-metal? Number 2, silicon is a metal. Is it true or false? Number 3, iodine can conduct electricity. True or false? And gold has a shining appearance and is malleable. Is it true or false? So let's look at hydrogen. Hydrogen is here. Silicon is here. Iodine is here. And then gold is here. So to determine this property, in fact this 4th question has to relate with whether they are metal or non-metal. So the first thing you should do is actually draw the staircase. And this is a zigzag staircase. They divide the metal from the non-metal. So all those on the left hand side are all the metals and right hand side are the non-metals. So hydrogen is definitely a non-metal because it's on the right hand side of the staircase. Silicon is also on the right hand side. If you look carefully, silicon is on the right hand side, so it should be a non-metal. But remember, silicon is somewhere between the metal and non-metal. It's considered as a metalloid. So it's not really a metal, but more towards a non-metal because on the right hand side. So it's a false, not a metal. Now iodine is right on here on the right hand side. Obviously iodine is a non-metal, and non-metal's characteristic is generally they do not conduct electricity. So metals conduct electricity, non-metals do not conduct electricity. So I would say that this is false. How about gold? Gold is on this side, on the left hand side of the staircase, and gold is a metal. And typically, if you remember how gold looks like, it's shining appearance and it's malleable. So all metals are shiny and malleable. So we can look at the elements in period 3. Okay, we're going to look at some trends across the period. So to make it simplify, instead of looking at this periodic table, okay, if you look carefully, we're talking about sodium, magnesium, aluminum, and so on. So let's look at a simplified version like this. Alright, so it's the same thing. Sodium, magnesium, aluminum across. So the top is group number, group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 0. Now you take note of this thing. You see that the first 3, sodium, magnesium, aluminum, they're all metals. So metals basically react by giving away electrons. So all these are metals, and the silicon is a metalloid. Somewhere in between metal and non-metal is a metalloid, and the rest are non-metallic, non-metals. Now take note of the nature of the oxides. You study this under the acid, bases, and salts, the nature of oxide. So the metals have either basic or amphoteric. So you realize that the first 2 are basic, and aluminum is amphoteric, and then after that will be acidic. So you realize that metallic property, if you look at this metallic property, it goes from metallic to the non-metallic. In other words, I can say that there's a decreasing metallic property. So the metallic property decreases from the left to the right. Alright? Or if you say that increasing non-metallic property also can, because it's getting more and more non-metallic from the left to the right. Okay, let's try this question. Sodium, aluminum, sulfur are the same period across the period. So how does the oxide changes in terms of their nature? Remember previously we just covered here, it goes from basic to amphoteric to acidic. So always remember this, basic to amphoteric to acidic. So it will be the last one, basic to amphoteric to acidic. Now you can talk about the period number and the number of electron shells. Which period do these elements belong to? There are some relationship between the number of electron shells and the period number. For example, you look at this one. Let's look at lithium, this beryllium, sodium, sulfur, and bromine. If you do not know their name, it is fine. You can find it in the periodic table. Let's focus on what we can find about them. All these are the proton number of this element given to you. So with the proton number, I will know that in any atom, the number of proton is equal to number of electron. So therefore, the configuration Okay, based on the number of proton is 3. 3 proton means 3 electron. 3 electron means the first shell there's 2, second shell there's 1. Okay, first shell only maximum up to 2, and then the second shell up to 8, and so on. So the configuration is 2, 1 for lithium, beryllium is 2, 2, and so on. So how many shells do we have that's filled up? You realize that number of shell, 1 shell, 2 shell. So it's 2, and therefore the period is 2. And next one is 2, 2 is also 2 shell, so therefore period is 2. 2, 8, 1, look carefully, 2, 8, 1, 1 shell, 2 shell, 3 shell. So their number of shell is 3 that's being filled. It may not be completely filled, but it filled up to the third shell for sodium. So it has filled up 3 shells, no, up to 3 shells, but not totally filled the last shell. Period is number 3, and so on. So you realize that for bromine, you can see that actually there's up to 18 for the third shell, but you don't study this in the syllabus, so don't worry about that. You just need to know that bromine has 1 shell, 2 shell, 3 shell, and 4 shells. So based on 4 shells, number of shells is 4, the period is also 4. So this is a key fact that you must know. You must really remember. The number of shells correspond to the period number. The number of shells correspond to the period number. So what determines the period number is the number of shells. Elements in the same period have the same number of electron shells. So if you realize that, see for example, they have 2 shells, they must be in the same period. If there are 3 shells, they must be in the same period number 3. Okay, to sum up what we've learned so far, okay, the number of shells correspond to the period number. So take note, number of shells correspond to the period number. So elements in the same period must have the same number of electron shells. So let's do a quick test. What do the 3 elements XYZ have in common? So XYZ is given here. This is the electronic configuration of XYZ. So what do they have in common? To look very carefully. So the number here, like for example 281, it represents 3 shells. So you realize that all 3 of them have 3 electron shells. So when asked what they have in common, you must say they all have 3 electron shells, and hence they all belong to period 3. Now next, group number and the electronic configuration. So we know that the number of electron shells will be representing the number of period, the period number. So how about the group? The group number is actually equal to the number of valence electrons. So if you look at the configuration here, for example for lithium 2, 1. Okay, the number of valence electron is the last number. Alright, so we call this the number of valence electron. So all the group 1 elements have 1 valence electron, and all the group 7 have 7 valence electron. So we can say that group 1 all have 1 valence electron, all the group 7 have 7 valence electron. So element with atomic number 16, it will be 286. So we know that 286 6 valence electron means it must be from group 6. Moving across the period, going from the left to the right across the period in periodic table, elements change from metallic to non-metallic. You must know this. Now what are metallic elements? How do you know they are metals or not? Metals have 3 or less valence electron. So for example 281, the number of valence electron is 1, so it is a metal. So if you have 3 or less, 1, 2, 3 valence electron means it's a metal, and metals will lose their valence electron to form a positively charged ion. For example, magnesium will lose 2 valence electrons to form Mg2+. And we can know that magnesium is a metal. Why magnesium is a metal? Because it loses 2 valence electrons. We know that magnesium is a metal because it loses 2 valence electrons. Whether you lose 1 or 2 or 3, as long as you lose valence electrons to become ions, they are metals. Elements with 4 or more valence electrons are non-metals. Now for non-metals, you have 4 or more valence electrons. For example, it's 286. When it's 6, means that actually there are 6 valence electrons, means it's a non-metal. So non-metals will gain electrons for other elements to become a negatively charged ion. For example, if you have 286, you gain 2 more. Alright? So for oxygen is 26. 26, it has 6 valence electrons, so it's a non-metal, and it can gain 2 electrons to form O2- ion. And it is a non-matter since it gains electrons. So we can actually define matter as element that loses electron, or non-matter as element that gains electron. Now, quiz time. Question 1. State the order by which the elements are arranged in the periodic table. By what order does it arrange in the periodic table? Answer is, elements are arranged in order of increasing proton number. Increasing proton number. Question 2. State what is identical in the electronic structures of elements in the same group. In the same group, what do they have in common? The number of valence electron. So the number of valence electron determine the group number. So all elements in group 1 have 1 valence electron. In group 2, 2 valence electron. In group 3, 3 valence electrons, and so on. So what is identical in the electronic structures of elements in the same period? The number of electron shells. Alright, so when they have same number of electron shells, the period number should be the same. Question 3. Explain why the elements in group 2 have similar chemical properties. They all have same number of valence electron, which is 2. So the number of valence electron determine the chemical property. When elements have same number of valence electrons, they react in a similar way. So all group 2 have 2 valence electrons, so they react in a similar way. Okay, next checkpoint. The diagram shows period 3 of the periodic table. Moving from left to right across the period. The elements, what do you think is the option? A, B, C, or D? Answer is obviously C. This is a very common question, make sure you know. Alright, element changes from metallic to non-metallic across the period. So sodium, magnesium, and aluminum are metals, and then it changes towards the other side. Silicon onward is a non-metal. Checkpoint 2. Which two numbers are metals in the same period? Same period means same row. So looking for metals, first you draw the staircase. Alright, staircase. Anything on the right hand side are non-metal, so don't need to look at it. I want metals only. So which numbers are on the same period? Same row. Obviously 5 and 6, right? Same row. So answer is D, 5 and 6. They are metals in the same period because they are same row.